Okay, so here is some short answer. Base your answer to the following question on the information below and on your knowledge of chemistry. The data collected by a student in a lab experiment is shown below. All kinds of information. State the number of significant figures in the mass of the beaker with the dry NaCl. Beaker with the dry NaCl. So 240.0. So since we have a number greater than 1 with a decimal place, we count them all. So that is 4 sig figs. These questions go out of order, but that's fine. Read the statement. If the statement is incorrect, write the word that would make the statement true. If it's true, just write true. Hats should always be worn with chemicals. So obviously that's not true. So we need to fix it. So what should always be worn with chemicals? How about goggles? You might say an apron, maybe gloves, but not always. Goggles is probably your best answer. During a lab activity, a student places 25 milliliters of HCl-AQ of unknown concentration in a flask. The student adds 4 drops phenolphthalein to the solution in the flask. The solution is titrated with 0.150 molar KOH until the solution appears faint pink. The volume of KOH is added. The volume that is added is 18.5 milliliters. Describe one laboratory procedure that should be used if a drop of KOH is spilled on the arm of the student. Obviously, you should tell the teacher. You should rinse under water. And I would monitor, possibly tell the nurse throughout the day. Please read this, and then it says, state the number of sig figs used to express the mass of hydrogen carbonate ions in the table above. So hydrogen carbonate, although we have not looked at formulas yet, the only one that contains hydrogen is this last one. So here's my number. When you have a number smaller than 1, obviously it has a decimal place, so we start at the decimal place and we count over. So 3 sig figs for that one. There's a story about Dmitry Mendeleev, which you obviously should read. It says, show a numerical setup for calculating the percent error of Mendeleev's predictive density of ES. So the predicted density is 5.5. So the measured value is 5.5 grams per cubic centimeter. The actual value is 5.324. Sorry, 3234. So numerical setup means you just put numbers in the formula but don't solve it. So it doesn't matter how you subtract. Eventually we're going to have a positive numerator. So measured minus accepted is what the reference table said. We must divide by the accepted, and then we must multiply by 100. You have to include that. You don't have to include units. You do not have to solve it. And in fact, you should not solve it. All right, so you got information. It says on the grid provided, mark an appropriate scale, and then we should plot the points. It doesn't say to, but we probably should. Okay, so we have to go from 18 to 49 grams of solute. So I don't know. Maybe we can go by twos. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. Wait. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 32, 4, 6, 8, 40. That's not going to work. I guess we could do less. I thought that seems to have worked here. Can't do that. Okay, and this is science because, sometimes we make mistakes. We could do threes. I guess. Because if we did 5, 10, 20, 30, 40, 50, that's definitely not using enough. So I guess we could do threes. 3, 6, 9, 12, 15. Here's 18, 21, 24, 27. This is 30, 33, 36, 39. Here's 39. I'm just putting up a random scale so we have it. All right, 39, 42, 45, 48, 51, 54. Okay, so then to plot, I guess I'll use a different color. So at 0, we would have 18, circle and circle that. At 20, we would have 20. These go by 3, so it's not quite there. 24 at 40, at 18, 21, 24. 60 is 29, so almost 30. 80 is 36, so that would be here. And 90, oh, there's no 90. 100 is 49, so this is just a little bit above 48. It didn't say to circle or connect. Usually it would just be a connect. Sorry, I didn't say to do best fit or connect. It would usually be just connect. Okay. All right. Show up numerical setups for percent error. So again, that's measured value minus accepted over accepted times 100. The measured value is what the student gets, which is 2.3. The true of graphite, which is 2.2, over the true, which is 2.2, times 100. You do not need to solve it because it's a correct numerical setup. Okay, that's it.